In this video, I'm going to look at how you can calculate enthalpy changes of formation from enthalpy changes of combustion. It's got a very standard question here where we've got some enthalpy changes of combustion values in this table here, and we're going to use them to calculate the enthalpy change for this reaction, which is the enthalpy change of formation of C9H20. And we've got to do it by using an enthalpy cycle. So because we're using enthalpy changes of combustion to do the calculation, we draw what's called a combustion cycle. So there's the reaction we want to calculate the enthalpy change for. I'm just calling it delta HX for the calculation. And this box here, I'm going to put in there the products of complete combustion of everything in the reaction. So 9 moles of carbon will give 9 moles of CO2. 10 moles of hydrogen will give 10 moles of H2O. And 1 mole of C9H20 will give those. So kind of that's how the cycle works. And because we're doing combustions, the arrows that we're going to use in the cycle are going to point down from the substances to the combustion products. So I'm going to have one arrow on the left hand side here to represent the combustion of these. I'm going to have one arrow on the right to represent the combustion of that. So using the table now, 9 moles of carbon is going to be 9 times that value there because that represents the combustion of 1 mole. So we're going to go 9 times minus 394. And as well as that, we've got 10 moles of hydrogen, so that's going to be 10 times minus 286. And then on this side, we've just got the complete combustion of the C9H20, so because it's just 1 mole, it's just minus 6125. So now we're bringing in Hess's law, so we've got these two different coloured arrows, so we've got the orange one and the blue one, and they're meant to represent the different routes from going from 9 moles of carbon and 10 moles of hydrogen to 1 mole of C9H20. So you can see there's your direct route, which has that enthalpy change. And then there's another route, you can go down to the combustion products and then up to the C9H20. So Hess's law basically says that the sum of the enthalpy changes in one route equals the sum of the enthalpy changes in the other route. Okay, so now we need to just think about the arrow directions in the blue route. So you can see that this arrow here is pointing in the direction of the route. So we can use the sum of those directly, which you can see I've already worked out, minus 6406. But then if you look at this part of the route, you can see the route's going like that. But this enthalpy change here that we've got is actually for this direction. So the way we get round that is we subtract this value. So we're just going to go minus and then the enthalpy change, 6125. So all we need to do now, put that in our calculator and you get minus 281 kilojoules per mole.